Hello everybody and welcome to this video. My name is Cliona, I'm a H1 chemistry student and today I'm going to be taking you through the solution to question 2 from the 2021 paper, and this is an experiment question from the organic chemistry chapter and it's based on the base hydrolysis of tri-ester molecules in coconut oil. Okay, so this question has 5 parts, A to E, and E is a calculations question. So let's get started now with question A. So the first part of question A is worth 3 marks and it asks us, why was the reaction mixture refluxed? Okay, so this is a really common question in the organic chemistry chapter where there's 1 or 2 experiments where refluxing is used. And why is refluxing used? It is used to speed up the reaction while also maximizing yield. Okay, and what does it mean by maximizing the yield? That means that it's preventing the loss of any materials while it's mixing them together. Okay, so if you say this, you will get your 3 marks for this question. Okay, so now let's move on to question part 2 of A. And question part 2 asks us to suggest a suitable heating method for refluxing the reaction mixture and then distilling off the ethanol. So when I was doing the Leaving Cert, I used a Bunsen burner with a wire gauze. If you used a heating mantle or if you used a water bath, feel free to put this down as well. You'll still get your marks. And for saying this, you will get 3 marks. Okay? So Bunsen burner with a wire gauze. I should also mention for this question, in the marking scheme, it says that if you do a clearly labelled diagram, that alone will also get you your 3 marks. Okay, so now question A part 3 kind of continues on from A part 2 and it asks us to justify the suitability of your suggested heating method. So if you didn't answer question part 2, you won't get your marks for this, okay? So I said that my apparatus was suitable because the flask is not directly heated, obviously because of the wire gauze, and the temperature is controllable. Okay, so this also will give you 3 marks, and also your answers here will be different. If the heating mantle, they mightn't be that different, but just make sure that it's suitable to your answer to part 2. So now we're just going to move on to the final part of part A, so the 4th part, and it asks us, why is it desirable to remove all the ethanol? Okay, and it is desirable to remove all the ethanol to maximize the yield of soap produced, okay? But why is this? This is because the ethanol would actually dissolve the soap if you didn't remove it, okay? And then if the soap is dissolved, that's going to minimize the yield of soap, and we want to get as much soap as possible. So for saying that this, again, you are going to get 3 marks. Okay, so now let's move on to question B. Okay, so the first part of question B asks us to name the co-product of the reaction, okay? And this here, I just copy and pasted out of the formula which is given to us at the top of the question, okay? Because you can clearly see that this is the co-product. So what I did is I could see that I have 3 carbon molecules, so it's going to be propane, okay? But we can see that 3 hydrogen molecules here, here, and here are replaced by hydroxide molecules or OH molecules, and they're on carbon 1, carbon 2, and carbon 3. So it's called propane 1,2,3-triol. It can also be called glycerol. Okay, so that's just glycerol is the same as propane 1,2,3-triol. Okay, and if you get this question right, you are going to receive 6 marks. Okay, so now let's move on to the next part of question B. So the next part of question B is a simple enough question. It simply asks us, what is brine? And brine is just salt water. It's salt dissolved in water. And for answering this correctly, you should get 3 marks. So now let's move on to part 3 of question B. And this asks us to explain the function of brine in the procedure, okay? And brine in this procedure, it dissolves the unwanted components out of the soap. And what are these unwanted components? You can put them in the answer just to make sure you're getting all your marks, but due to this marking scheme, you would have got full marks by just saying that it dissolves the unwanted components, but it dissolves NaOH and glycerol, or propane 1,2,3-triol. Okay, so it dissolves those out of the soap so that we're left with just soap, because that's all we want. Okay, and for saying this, you will get 3 marks by just explaining the function of brine in the procedure. Okay, so now let's move on to question C. So there's just two parts to question C. This first part asks us to describe how the solid soap was separated from the solution in the beaker. So it's just asking us really for a method of separation, okay? So if you remember back to just doing the experiment, that's always the best way when you're answering these questions. Just put yourself back into the lab where you're doing the experiment and you're kind of thinking, what did I do then? And I remembered that the soap here was separated from the solution by filtration, okay? So filtration here is our key word. And for this question, you are going to get 6 marks, okay, for just suggesting that it was filtered out. So now let's go on to the second part of question C. And question C part 2 asks us, where is the excess NaOH at this stage of the procedure? So if you remember back to the question which asks us about the function of brine, okay, I suggested that it dissolved NaOH out of the soap. So the NaOH is actually dissolved in the brine, okay? And the brine is the filtrate, so you could also say that it's in the filtrate. You'll still get your marks. And the marks going for this question is 3. So it's 3 marks for suggesting that it's dissolved in the brine, and that's the filtrate. Okay, so now let's move on to question D. So question D is there's just one part to question D, and it tells us that the diagram, and there's a diagram shown in the exam paper, but it's not really of much use in the question, okay? So it just says the diagram represents the arrangement of a number of soap molecules in water, okay? And the question is to explain why one end of the soap molecule is described as water-loving or hydrophilic. Okay, so why is one end of the soap molecule described as hydrophilic? Okay, and this is because one end of the soap molecule is actually polar or ionic, and so is water. So then this end of the soap molecule dissolves in water and can be described as hydrophilic, okay? So if we look at, this is the soap molecule, I just copied and pasted it from the exam question, okay? So then we see this end of the soap molecule, COONA, okay? That is actually ionic. So that can be written as COO minus Na plus, okay? So that is polar, and water is also polar, okay? So when two molecules are polar, they're going to dissolve in each other, okay? And for this question, you're going to get 6 marks, okay? So you can explain it in words, and even if you just wrote that COONA, which is this part of the soap molecule, that can be written as COO minus Na plus and stated that that was polar and that water is polar, you'll also get your 6 marks. So now let's move on to question E, which is the calculation part of the question. And in this question, we are told when 0.03 moles of the tri-ester shown in the equation above are hydrolyzed, what is the theoretical yield in grams of CH3, CH2, 10COONA, which is just the soap. So we know that we have 0.03 moles of this tri-ester, okay? And we want to know how many grams of soap we're going to get. Okay, so how are we going to do this? First of all, if we have 0.03 moles of the tri-ester, how many moles of soap do we have? So it's 1:3, because there's 1 mole of this tri-ester, because there's no number in front of it, there is 3 moles of soap. Okay, so I'm just going to rub that out there in case we get confused in a second. So if there's 0.03 moles of the tri-ester, there's going to be 0.09 moles of soap. Okay, so I have soap here. Number of moles is equal to, so N stands for the number of moles, 0.09. Okay, and the formula to get the mass of soap is going to be M, which is mass in grams, is equal to M, okay, which is the relative atomic mass, okay, and then multiplied by N, which is the number of moles. Okay, so how do we find the MR of soap? So I'm just going to go over here. So MR of soap to find the mass of soap. Okay, so also I should just mention, this question altogether is worth 9 marks. You would have got 3 marks here for just finding out how many moles of soap we have. Okay, you're going to get another 3 marks here for working out the MR of soap. Okay, so you're going to need to go to your tables, okay, for this question. And So how many molecules do we have, or how many atoms do we have? So we have carbon, we have hydrogen, and we have oxygen, we have sodium. I think that's it. Okay, so how many carbon molecules do we have, or atoms do we have? So we have 1 here, there's 10 here, and 1 here. So 12 carbon atoms, okay? Hydrogen, we have 3 here, we have 20 here. So 3 and 20, so 23 hydrogen atoms. How many oxygen atoms we have? Just the 2. And how much sodium? We have just the 1, okay? So now we multiply these by all of their masses, molecular masses, okay, which can be found in the tables. So carbon is going to be 12, hydrogen is just 1, oxygen is 16, and sodium, I'm just going to have to check there. Sodium has a mass of 23. Okay, so now we're going to multiply. So 12 by 12 is 144. 23 by 1 is just 23. 2 by 16 is 32, and 1 by 23 is 23. Okay, so now let's add 144, 23, 32, and 23. Okay, so pop that into your own calculator there, and you'll get an answer of 222. So the MR is equal to 222. And if you get that, you will get your 3 marks going for this. Okay, so now we have the number of moles and we have the relative molecular mass. Okay, so now we can find the mass in grams. So M is equal to big M, which is the relative molecular mass, which is 222, multiplied by the number of moles, which is 0.09. So the mass is equal to, and again, use your calculator for this, so 222 multiplied by 0.09, and this gives us an answer of 19.98 grams, okay? So this is our answer, and this is where your last 3 marks are going to come from. Okay, so that's the end of this question. And just a point to note, for these calculation questions, as you can see here, you got 3 marks for just converting the number of moles of the tri-ester to the number of moles in soap. You got another 3 marks for working out the relative molecular mass. So if you're stuck in a calculations question, just do something, do anything that you know how to do, okay? They're trying to find the theoretical yield of soap, okay? Find the MR. You know how to find the MR, you'll get 3 out of 9 marks at least, okay? So just always give it your best shot to pick up the marks wherever you can. So I hope that you found the solution video helpful and that it might have cleared up any questions that you might have had in relation to the question. So thank you for watching, and I'll see you in the next video.